Welcome to Edgecore Enterprise Switches Training Program. A virtual local area network, VLAN, is a technology that allows network devices to be logically grouped into separate broadcast domains, regardless of their physical location or connection. In this video, we'll introduce the 802.1Q VLAN concept and how to configure VLAN on Edgecore Enterprise Switch. A LAN, or local area network, is a way of connecting computers and other devices that are close to each other, such as in the same room or building. A LAN allows the devices to share files, printers, internet access, and other resources. A LAN is a single broadcast domain, which means that any device that sends a broadcast packet will reach all other devices on the same LAN. However, if there are too many broadcast packets on the LAN, it will cause a broadcast storm that will reduce the network performance. VLANs or virtual LANs can divide broadcast domains into several LANs. VLANs are logical groups of devices that share the same broadcast domain, regardless of their physical location or connection. A VLAN ID is a number that identifies which VLAN an Ethernet port belongs to. In this figure, we use different colors to indicate the VLAN ID of the ports. Only the interfaces in the same VLAN can communicate with each other. In this example, we create 4 VLANs for different departments on switch 1, which means we have 5 broadcast domains. That's because all ports join VLAN 1 by default. The broadcast packets only be forwarded to the members in the same broadcast domain, for example, the same VLAN. Trunk mode enables the switch to transmit and receive traffic from multiple VLANs through one interface or port channel. This allows us to span VLANs over several switches, enhancing our network's adaptability and scalability. VLANs have the following benefits. Network performance. VLANs can improve network performance by reducing network congestion and limiting the broadcast traffic to a smaller domain. Security. VLANs can increase network security by isolating devices and restricting unauthorized access. Scalability. VLANs can make network management easier by enabling devices to be moved, added, or changed without affecting the physical wiring or configuration. Management. VLANs can accommodate different user groups or applications by creating logical segments that have specific policies or requirements. In this section, we will explain how VLAN works and cover the following topics: ingress-egress rule, switch port modes, forwarding table, and VLAN tag. VLANs have many applications, such as MAC-based VLAN, voice VLAN, dynamic VLAN, and so on. Before using these functions, we need to understand how VLAN works and how to configure VLAN on switches. In this video, we will introduce the VLAN concept and demonstrate how to configure 802.1Q VLAN on Edgecore Enterprise switches. Then, you can design your network according to your needs using these VLAN features. The ingress and egress rules can be applied on the interfaces. The interfaces can be a single port or port channel. This figure illustrates the process of a packet entering the switch and the number of rules that it has to pass before being forwarded. The switch checks the acceptable frame type before ingress rule checking. There are 2 options on this command. When configured to all, the port accepts all frames. Any received frames without VLAN tags will be assigned to the native VLAN of the port. If the acceptable frame type is set to tagged, the untagged frames will be dropped, and the tagged frames enter the ingress rule checking. If a port has disabled the ingress filtering, and it receives frames with VLAN tags that do not match its VLAN membership, these frames will be sent to all other ports that belong to the same VLAN ID as the frames. If a port has ingress filtering enabled, and it receives frames with VLAN tags that do not match its VLAN membership, these frames will be dropped. When the frames have passed the ingress rule, or added PVID tag, the packets will be forwarded based on the forwarding table. The egress consists of 2 parts: the VLAN membership type and switch port mode. The switch port mode decides whether transmit packets are tagged or untagged, when the port mode is trunk mode or access mode respectively. When the port mode is hybrid, it depends on the settings of joining VLAN membership type. There are 3 switch port modes on the interfaces: access, hybrid, and trunk. An access port connects endpoint devices, such as computers or printers, to the network. The access mode can join only one VLAN and send and receive untagged frames. By default, all ports on a switch are in hybrid mode. The hybrid mode can join multiple VLANs and transmit or receive tagged or untagged frames. It is flexible and easy to use. When we connect 2 switches, we can configure the switch port mode of the interfaces between 2 switches to trunk mode. The packets on this link are all tagged. Note that frames from the port's native VLAN are also tagged. VLANs are configured on switches on a per-interface basis, such as port or port channel. They logically separate end hosts at layer 2. The Ethernet switch forwards packets based on the MAC table. In our example, we use show MAC address table command to view the MAC address table. You can see the MAC addresses learned on port 3 and port 4. They both belong to VLAN ID 4094. This means they are in the same broadcast domain and can communicate with each other using unicast, multicast, and broadcast packets. In the second example, we use show MAC address table VLAN 200 command to view the MAC addresses learned on VLAN 200. This means they are in the same domain. The IEEE 802.1Q standard specifies how to add VLAN tags to Ethernet packets. A VLAN tag is a 4-byte data field that is inserted between the source MAC address and the original ether type of the packet. The VLAN tag has 4 fields. A 2-byte protocol ID, TPID, that is set to 0x8100 to indicate an 802.1Q frame. A 2-byte tag control information, TCI, that contains a 3-bit priority field. A 1-bit canonical format indicator, and a 12-bit VLAN ID. VLAN ID 0 and 4095 are reserved, so the configurable ID ranges from 1 to 4094. In this figure, we can see the VLAN tag is between the source MAC address and the original ether type. 8100 indicates the IEEE 802.1Q frame, and the VLAN ID is 100. When the connected device cannot send and receive frames with VLAN tags, we can set the interface to access mode or hybrid mode. In this example, we use white color to indicate access port in native VLAN 2. When PC2 wants to send a document to the printer, the frames from PC2 are untagged. Once the frames enter port 14, they will be tagged with native VLAN ID 2, and then forwarded to port 1, which has switch port mode as trunk. Port 1 sends packets with VLAN tag 2 to port 21 on switch A, and port 21 forwards the packets to port 2. Port 2 removes VLAN tag 2 before sending it to the printer. The access or hybrid port adds a native VLAN tag to the frames that do not have a tag, and then forwards them to the same VLAN member ports based on the MAC table. When sending frames from the access port, the VLAN tag will be stripped off from the frame. Next, we'll introduce VLAN-related commands, such as creating VLAN, configuring switch port mode, and ingress/egress rule, native VLAN, and VLAN trunking. On Edgecore switches, all ports join to VLAN 1 by default. All untagged or VLAN ID 1 tagged packets will be forwarded to other ports based on the forwarding table. The broadcast or multicast packets will be flooded on the whole switch. That means a switch is a single broadcast domain by default. This table displays the default setting of VLAN function-related parameters. We'll show you how to configure them. Before creating a new VLAN, when we type show VLAN, we can see there is a VLAN ID 1 already configured on the switch by default, and all ports join the VLAN 1. Use VLAN database command to enter VLAN database mode to add, change, and delete VLANs. We can create a single VLAN ID and assign a name for the VLAN. We also can use a hyphen to create a range of ID. The VLAN ID is ranging from 1 to 4094. If the VLAN ID that we want to create is not continuous, we can separate these non-consecutive VLAN ID with a comma and no spaces. When we want to delete VLAN, we can use no VLAN command to delete a single VLAN or a range of VLANs. When the interface is set to receive all frame types, the untagged frames are assigned to the default VLAN and entering the forwarding process. The tagged frames are checked by the ingress rule. The default acceptable frame type is all frame types. We can use the command switchport acceptable frame types tagged to make the interface receive only tagged frames. We can use the command no switchport acceptable frame types to reset the setting to the default. By default, ingress filtering is enabled on an interface. The switch will discard frames that have VLAN tags that do not match the interface's VLAN membership. The frames that match the VLAN membership will be forwarded based on the MAC address table. When set the ingress filter to disabled, the switch accepts frames with any VLAN tags, regardless of the interface's VLAN membership. We can type switchport ingress filtering to turn on the ingress filter. Type no switchport ingress filtering to disable this function. The switchport mode command configures the VLAN membership mode for a port. The default setting is the hybrid mode. It can transmit tagged or untagged frames. If the connected device is VLAN unaware, we can type switchport mode access to configure the port as access mode. If we want to connect a port to another switch and allow it to carry traffic with multiple VLANs, we can type switchport mode trunk. The frames are always tagged within the switch. The tagged-untagged parameter used when adding a VLAN to an interface tells the switch whether to keep or remove the tag from a frame on egress. For access mode, it can only join one VLAN with untagged. If we add multiple VLAN with tagged, we'll get an error message. Says failed to join egress list on Ethernet port. For trunk mode, it can join multiple VLAN with tag. If we add VLAN with untagged, we'll get an error message. Says failed to join untagged list on Ethernet port. We can join a range of VLAN IDs using a hyphen, or if the VLAN IDs are not consecutive, we can use a comma without spaces to separate them, followed by the tagged or untagged parameter. When we want to remove a VLAN from an interface, we can use the remove parameter to remove a single VLAN ID or a range of VLANs. On Edgecore switches, all ports join to VLAN 1 in the default setting. When we type show MAC address table, we can see that all frames are learned on VLAN 1. We can type show interfaces switchport Ethernet with interface ID to display the VLAN membership mode in native VLAN ID. The native VLAN, also known as default VLAN or PVID, is the VLAN that untagged frames belong to. When an interface in access mode is assigned to a new VLAN, its PVID changes to that VLAN ID. When an interface is in hybrid mode, we can use the command switchport native VLAN, followed by the VLAN ID to set the PVID. To view the VLAN settings of a port, we can use the command show interfaces switchport with the port number or the port channel ID. This will show the VLAN membership mode, ingress rule, acceptable frame type, native VLAN, and the VLAN IDs that the port belongs to. The U indicates untagged, T indicates tagged. VLAN trunk allows unknown VLAN groups to pass through the specified interface. Use this feature. We can configure a tunnel across one or more intermediate switches that pass traffic for VLAN groups to which they do not belong. This figure shows VLANs 10, 20, and 30 are configured on switches A and B. We don't need to create VLAN 10, 20, and 30 on the intermediate switches, only need to turn on the VLAN trunking function. The switches C, D, and E will allow frames with VLAN tags 10, 20, and 30 to pass through their VLAN trunking ports. When switch A and B create more VLAN, we don't need to change the settings on the intermediate switches. To configure VLAN trunking, we have to set the switchport mode to trunk and turn on VLAN trunking for ports C1, C2, D1, D2, E1, and E2 on the intermediate switches C, D, and E. Without VLAN trunking, we would need to create VLAN 10, 20, and 30 on all intermediate switches C, D, and E. The port C1, C2, D1, D2, E1, and E2 would also need to be configured as trunk ports and join VLAN 10, 20, and 30 with tags. Any changes to the VLAN ID on switch A and B would require updating the settings on the intermediate switches. Whether to use VLAN trunking or not depends on the user's environment. The system administrator should plan and document the network well for good management. We hope this video can help you learn the 802.1Q VLAN concept and how to set up VLAN on your network. Thank you for joining us. If you have any questions, please feel free to contact us anytime.